Hi, this is the Level Up Engineering Podcast, where we talk with some of the most successful engineering leaders who reveal actionable management insights that help you take your developer team to the next level. This episode is brought to you by Coding Sans, a software development agency building web applications from design to delivery with React, Node.js, and Angular. Check them out at codingsans.com.
Hi everyone, Carolina Toth speaking, and this is the Level Up Engineering Podcast. In every episode, we talk with accomplished engineering leaders about different kinds of leadership challenges they face. Before we get into today's episode, I'd like to share with you that if you sign up for the Level Up Engineering newsletter, you're going to receive new episodes 2 weeks prior to them being released to the rest of the world. So it's a really good deal. Click the link in the description and join our engineering leadership community. Today, I have a very special guest, Patrick Roy, who is a seasoned technical leader. You can follow him on the internet, read some of his blog posts, and you can also see some of the videos that he has shared of his work at various conferences. So welcome to the show, Patrick. And please, if you could introduce yourself to our listeners a little bit, if they haven't had the pleasure of meeting you, that would be great. And also if you could share some of your passions.
Great. So thank you very much, Carolina, for having me on the Level Up podcast, and glad to be here today. My name is Patrick Roy, as you said. I've been working in technology for about 20 years, so I've seen a lot of change over those many years, not only just about the industry itself, but also the role that technology plays in everyday work. So, I think it's a bit inescapable these days in that tech is embedded in everything. But when I first started, it was very different. I started off as a software developer as well. So I started working off with companies like Oracle and Flight Centre in Australia. And I spent a lot of my time consulting. So I worked with ThoughtWorks for about 14 years. And over that time frame, I got to see lots of different companies at different scales and sort of stages of their life. So some companies that were like startups going through their product discovery phase, some of the companies that were going through their scale up, really trying to get bigger and better, but to do so more effectively. And I've also worked with a lot of the sort of enterprise companies that have been around for maybe 20, 50 years and trying to be, maybe more agile, more adaptive to move towards continuous delivery and think a lot more like a tech firm. I've played lots of different roles across that time. And I've also played a CTO role of a scale up for a bank in Berlin called N26. And now I'm working as an independent sort of technical coach. So I work with CTOs and VP engineers, helping them grow themselves and also to help them navigate the challenges of their sort of growing companies. So I think in our industry, it's interesting because, the CTO role has changed and evolved. It's kind of emerged over the last 10, 15 years, but there's no real single sort of definition and every circumstance is different. But a common situation that a lot of people find themselves in is that you feel very lonely. True of any leadership role, but when you're in that sort of CTO role, there's no one generally above you that you can sort of connect to that has that sort of background. So I like supporting people with coaching and mentoring in the sort of one-to-one space. And I also run a lot of training for technical leaders. So I run a workshop called Shortcut to Tech Leadership that helps particularly first-time engineers or technical folks step into a technical leadership role. I think that transition is probably one of the hardest transitions. I think any leadership transition is always hard. But I think for engineers, there's a lot more surprises than other people when they transition into that. So that's one of my sort of personal passions of helping people grow. I've written a number of books. One of the books is actually called Talking with Tech Leads to help people with this journey. I wrote a book about building evolutionary architecture with a couple of co-authors, Rebecca Parsons and Neil Ford. And I also run a newsletter also called Level Up, which is aimed at helping people level up their technical leadership skills.
Right. Thank you so much. You have a lot of experience and I'm very glad to have you with us today. And also, I am so excited for our topic. You have published some things about systems thinking, and I thought it would be really great to sort of discover this topic and share with our listeners as to how systems thinking can be useful for leaders, and especially in the IT industry, but in any industry, I feel. So before we do a deep dive. I am personally only more familiar academically with complex systems because of my background. So if we could define what we mean by systems thinking for the purposes of our conversation, that would be really great. And also to perhaps see where it's coming from or what its core building blocks are.
Great, absolutely. Yeah, we can definitely talk about that. Maybe to start off with, I think a good comparative trust is thinking about how people maybe learn and what they're taught in schools. So I think if we compare it to perhaps the scientific method or what is typically taught in schools, guessing mostly around the world, I think one thing with science is that you tend to run experiments. And when you think about experiments, you think about repeatable things, you test a hypothesis. But the way that we're sort of taught science is by looking at a sort of reductionist view. So we tend to have a controlled environment. We want to have repeatable elements, and therefore we can understand the sort of cause and effect. And this is kind of considered this sort of reductionist movement. We're trying to understand what thing causes another thing. And, we see this and in the way that we think about life because we're taught this approach in a lot of our schools. If we compare that sort of approach to systems thinking tries not to look at the individual parts. So like in complex systems, one of the characteristics of systems thinking is you get sort of emergent behavior. So things that the individual parts by themselves don't have, that, if you inspected them individually, you would never get a sense of that. In the real world, a really good example is human life, right? So we're all made up of parts. We have skin, we have blood, we have brains, but actually there's no such concept of life in each of those parts. It's somehow when we have all this combination of all these things working together, do we have this emergent property, which is called life, right? We're living, we're thinking, we're imagining, we're dreaming. And so that's the kind of idea behind sort of systems thinking, which is to complement scientific reductionist thinking. It's still important, but to understand that there's not necessarily, particularly with complex systems, that's the only approach you should use. So we should take a little bit more of a holistic approach. And there are some characteristics of systems. So one of those things is, trying to understand where do you draw the boundary of a system. Somebody's definition of a system might be different because they're thinking of a different boundary. And so that's an important part of systems thinking, is to try to think about, what's the purpose of why you're trying to think about systems and how you're using it. Because if somebody has a different purpose, they'll probably come up with a different perception of what their system looks like. So there are a couple of characteristics of how I'd think about systems thinking. So thinking about that sort of emergent behavior, not trying to look at the individual parts, and trying to understand why you're thinking about using systems thinking.
Right. For those of us who are listening to us, I am really loudly nodding my head at everything that Pat is saying. It all sounds really great. And to me, it sounds very obvious in a sense. I feel like a lot of our listeners have a sense of like, duh, obviously, like we are all made up of dynamics and different kinds of environments and situations. But could we dive in a little deeper and see a couple of examples as to how systems thinking can be applied in general and within the context of leadership in IT?
Absolutely. So I think a really classic example is when we look at most people are working in teams building software. And so we can think about a team as a system, and we can apply systems thinking in that perspective. If we don't apply systems thinking, one model that leaders or managers might think is that, we can swap people out and we'll always get the same performance out of a team. Right. So it doesn't matter if we lose somebody, we can just swap them out, or maybe we can move from people from one team to another, and they still expect that team to behave exactly the same. And so this is that sort of reductionist thinking of thinking about the parts. All parts are interchangeable or swappable. But if you take the systems thinking perspective, you understand that, okay, the performance of the team effectively is emergent behavior. So it's the interactions of how the people work. And I'm sure you've probably worked with teams where you've kind of gone, oh, wow, like this is a team that definitely those interactions aren't working so well. They definitely need some sort of help. So that's an interesting perspective, particularly for leaders, because you're accountable for the performance of your teams. And so, it's not just about who you have in the teams, but also about the interactions between them. And so that's the interesting element of systems thinking, is that once again, you can't just look at the parts and go, I've got a great engineer, I've got a great designer, I've got a great product person, let's throw them together and they'll magically work as a high-performing team. That rarely happens. There's a lot of effort in building trust, building relationships, and helping clarify things like roles, responsibilities, expectations, team norms, which are all about the interaction. So how do we as individuals work together? And so if people who are listening, you've probably experienced this when you've maybe swapped teams, is that maybe you were working in this like amazing environment, you got along with everyone understood how you worked. You then start maybe the new team, new company, and it's like, wow, it couldn't be any different, right? So at the base level, we still maybe have the same roles, but we have different people. And more importantly, we have a different environment and different constraints. One of the things I really appreciated from consulting is I got to see lots of different environments and lots of different sort of constraints. At an organizational level, one constraint that maybe affects teams' performances, for instance, is things like what are the processes, right? So I've worked in teams where you might call them a bit more like Scrum or strict Scrum, where it's like 2-week planning, and every Monday there is some planning session and there's the sort of sprint review 2 weeks later. I've also worked in startups where there isn't really this sort of strict 2-week kind of sense, and they're deploying continuously, iterating, they're getting together each day as a team and saying, hey, what do our users need? What's the data? What can we experiment with? And so the sort of organization culture is also something that constrains the sort of dynamics of the team. And so it's another element that comes into play that maybe outside of the team's control, because maybe some other people are encouraging the certain process. And so as a systems thinker, this is one of the things I tend to think about when I'm thinking about if you want to transform a system, what are the sort of different components? What are the elements that make up that system? And that's why it's important to always think about what's your purpose, because you can keep expanding it to include so many different elements, but you have to sort of always decide what you want to sort of focus on. And then you want to explore the interactions between the elements to try to understand what are the dynamics, but also what are the things that you could potentially shift. I've worked in software teams where you had to follow a certain process because that's what the organization demanded, right? So early on in my career, that process was you had to write a requirement specification. It had to be signed off by product people or business people, had to go through all these rigorous reviews. In a team, that's something that you probably can't influence and change. And so that's why it's also important to understand, these are elements. Sometimes those elements are external to your control. They may feel frustrating, but you might need to treat it as a constraint for the time being, rather than something that you can actually change. There's a lot of things within your control as a team member that you can change, right? So you can agree with your team how you'd like to work differently with them. You can agree if you want to do pair programming or mob programming, or if you want to go for more asynchronous code reviews, for example, right? You can agree as a team about how often you coordinate and synchronize information. I think that's one of those things where I've worked in teams where like literally people were allocated tasks in tickets, and like it was so silent that I wouldn't describe as a team. It was a bit more like a feature factory or people sort of working as individual streams, but it didn't really feel like a team. And, I compare that to another team dynamic where the people agreed to do a lot more mob or pair programming, where it felt like it wasn't individuals' work, but it was actually a team effort towards the team goal. And so there are sort of elements that you can control within that sort of team. So I hope that gives you a good example of what I mean by systems thinking in a software context.
Sure. Thank you so much. A couple of things. I really have to hold myself back from kind of discovering what some of the implications might be for the scientific inquiry, but this is not our core purpose here. But I also keep coming back to this word holistic. I feel like about 20 years ago, it was overused a little bit. And so some professionals in the industry might be a little reserved from using the word holistic or the concept maybe. Could you elaborate as to how systems thinking can be more than the sum of its parts, how we can look at teams and see what holistic really means for our team in particular?
It's a tricky question because I think this is a question of what your scope of your system is. And so this is where one of the important parts, I think, of systems thinking is you rely a lot on, or it's a good practice to try to draw a visual model, because you and I might be talking about holistic in the same word, but we may have different, it's likely we have different understandings about what we mean by that. Is holistic, the team is holistic, the team of teams, the product is holistic, the whole company and its sort of supply chain and partner chain, right? So that's one of the dangers with systems, is that you can kind of keep extending it to encompass everything. And which is why it's important to use visual models when you're using this in discussion to try to draw your boundary of a system. Because before you know it, you're encompassing legal, regulatory requirements, everything that it's fascinating to understand all the effects, but maybe not so useful for whatever purpose you have.
Right.
So as an example, right? So if I think about holistic, one perspective is I've worked with companies where teams are relatively stable and they're working as a team. So they're working with each other, but there's a lot of conflict with other teams, right? So it might be about different dependencies or about something that they need. So maybe it's an API or a data feed from another team and they're not getting that. One of the interesting holistic properties you might look at is, are they actually a team independent of other teams? So are they actually sort of working on an individual product that is more or less independent? And in some organizations that I consulted in, after doing a bit of inquiry and exploration, I started to understand, I'm thinking about one particular example, where in order for one team to achieve its particular goal, they were working on a particular project, they needed this other dependency from another team, but that team was working on a different project altogether. So it was something that was out of their control. And so this kind of dependency indicated that they weren't really working as a different product team, but they were actually working on the same product. And so this is something that I often explore with a lot of organizations, is that somebody might call themselves a team because they happen to be co-located, or at least they've got a name for their team with a small group of people. But if I'm exploring, I might actually find that you add 2 or 3 different teams together and they're all working on the same product. From that sort of sense, then, a different way of thinking about that is that all of you are actually working in a bigger team. You just happen to have a different work structure of dividing work, right? And that's very different if you have a different company that I'm thinking about, is where this company had different types of products and they literally had different teams working on each of those individual products. There was no reason for them to have to talk to each other, and there was no reason for them to have to coordinate dependencies or to plan dependencies, because they were very different product streams. And so even though you have the same term team, you have a different holistic behavior of, if they're all working on the same product, there's a lot more coordination or dependency planning or frustration because people aren't working in sync. Whereas a different sort of organization where you have 3 teams independent of each other, really working on different products, they could be a lot more effective and not have to coordinate with each other. And so that's something when you look at organizational structure, which is appropriate for technical leaders, is that you also need to think about what should be the relationship between those teams. The good thing is we improve continually as an industry. And I think over the last year or so, one of the better books in this area, one of the better sort of ideas in this area is the work around team topologies. So the team topologies give us 4 different types of team constructs to try to understand how do we plan our organization to try to minimize coordination and to sort of balance out, do we need some teams sharing the same ideas? And so in order to apply team topologies, I think part of that is thinking about what is that whole, what is that holistic picture? And so I think that's why, I think it's important to draw the boundary when you're describing what holistic means, because we'll often have different ideas.
I love it. Thank you so much. With that said, let's jump into some of the challenges that tech leaders might be facing if they want to sort of bathe in this systems thinking approach. What are some of the drawbacks that they might face, or what are some of the mistakes that they should avoid?
So I've got a course on the Tech Lead Academy about systems thinking. One of the ideas that we cover in there is this idea about feedback loops. And so feedback loops are there, so we have to acknowledge them. And sometimes short feedback loops are good, right? So as a developer, if I write some code, I want to get some quick feedback about whether or not it's working or not. Because if I continue to build on something that's not working, I have the potential of throwing away a lot of code or having to rebuild everything in order to make it work properly. And so there's that sort of feedback, which is important to think about, and that speed of that feedback. And so, I think that's one thing that leaders should be looking at, which is to notice what feedback loops you have in place, what's the speed of them, and is the speed enough? Now, speed isn't always a good thing. So this is something else which is hard, and that's one of the tricks of applying this, and one of the traps to answer your question, is that it's sometimes appropriate to have slower feedback loops. So as an example, today, everything is so interconnected with each other, right? So Wi-Fi networks, and this is something that if you've worked in security in your organization, the blurring, particularly with home and office networks, is a nightmare, right? So as an example, if you have a virus that joins the network, so somebody's laptop or PC gets infected, it's not a great thing that there's a short feedback loop to propagating that virus across your entire network. That's a bad thing. We probably see this in real life with Corona, right? Which is like a fast spreading rate. So short feedback loop is not ideal when you have a deadly virus, right? So this is where buffers and things that slow that down, and that's what, moving to the real world type stuff, that's the purpose of things like vaccines and masks, social distancing, is to slow that down, because in a case where something is rapidly escalating, we want to slow that feedback loop down. So we can apply that in software as well, as that, depending on the type of feedback loop that we have or the nature of what you're looking at, some feedback loops are good to decrease. So that sort of speed of feedback, am I writing good code? But similarly, fast feedbacks in the wrong instance, like sharing viruses, is not a great thing to accelerate. This is where you want to have buffers and break zones. Similar, if we think about software architecture, if we think about external service and there's a timeout, if there's an error on that external service, if you have a fast feedback loop, that can rapidly move towards your entire stack, which brings down your service as well. And so a very common architectural pattern here is a circuit breaker, right? So a common approach here is if an external service goes down, you might try a retry. But if it doesn't respond, you might want to slow down those retries, or at some point have an alternative way of dealing with it so that the rest of your system can go unaffected based on an externality that you can't control. So this is one of those challenges with systems thinking, is you have to be aware about your environment. So you have to understand what are the characteristics, what are the interactions, what are those feedback loops, and are those feedback loops with the right sort of speed? And so I'm not going to say you should decrease feedback loops, because it really depends on what characteristics you care about, but I think you have to be aware of what they are. And so one of the other traps is, if you're not aware of those feedback loops, what's very common is you might react too quickly, particularly with slow feedback loops. A good example that I can think about is, or maybe a slow feedback loop is, if people only get feedback once a year, at some point you're going to be surprised as a leader manager of somebody quitting, right? So you don't have any sort of expectation or shared expectations. And one of the purposes of feedback is to help people grow, and also to calibrate, are people doing okay? One of the good practices as a manager is do regular one-to-ones with your team so that you get a sense of how's their temperament. Are they engaged? Are they on the point of burnout? Are they bored? What do I need to do to change that system? If you have a long feedback loop, so you don't have one-to-ones, and I know of some bad managers that don't do one-to-ones, or you don't do one-to-ones very regularly, so I know of other people that maybe check in with people once every quarter, then that's not going to give you a chance to really react to that, right? Similarly, you might be having weekly one-to-ones with people in your team, and somebody is coming to you really frustrated, right? And it might be a bit of a rant, and you decide to do something about that. But sometimes that's one of the other interesting things with systems, is that you maybe don't want to react immediately, because it could just be that day. It could just be somebody's having a really bad day, and you don't want to change the entire team process just because one person's having a bad day. You kind of need to get that feedback in a sense of, is this a repeated pattern, or is this something that the system is contributing to? And so this is, once again, one of the challenges. There's a lot of judgment involved in trying to work out when's the right time to intervene and at what level to intervene in order to use systems thinking.
Before we continue with the second part of this episode, let me tell you a little bit about Coding Sense, the sponsor of the podcast and the company I work for. We are a full-stack web development agency building complex, market-ready products from design to delivery. We work with the latest web development technologies such as React, Angular, and Node.js. Our team has extensive experience with all cloud providers and production experience with serverless technologies. If Level Up Engineering has been bringing you value, consider Coding Sans to build your product. Check us out at codingsans.com. And now, back to the show. While you were speaking, my thought was that it sounds like applying systems thinking is a model that kind of incorporates a lot of very different things within leadership and gives you somewhat of a framework to not forget perhaps any aspect of leading your software development team. And with that said, if that's true, I hope that is. If not, then please feel free to correct me. What are the steps of applying systems thinking if a software engineering manager is listening to us? What should they be doing if they want to involve systems thinking in their leadership?
So just to comment on what you said, I know lots of great leaders and managers out there who I don't know if they're applying systems thinking directly, but they can also be very effective, right? So excellent communicators, excellent negotiators, listeners, people who can plan, manage risk. A lot of those activities are also great leadership, but not necessarily systems thinking tools. What I think of is that systems thinking sort of adds another thing into your leadership and management toolkit that will help you, in these different circumstances, as you said, to not forget about lots of different elements. But a simple way to apply systems thinking if you're a software engineering manager or a leader in this sort of environment is particularly for some of those complex problems that never go away. They seem to keep coming back again and again, right? So you've probably had something like that. And so that's a good use of systems thinking. So if you can sense a issue, something a little bit weird in code, we talk about code smells. You might apply that same idea, process or organizational smells. Is there something that's happening on a regular basis that you've tried to do something about and it keeps coming back, or there doesn't seem to be anything there? This is where systems thinking might be useful because it's going to help you hopefully get a different perspective. When I've applied systems thinking, the first thing is to understand what is that issue or thing that you're trying to get awareness of or better understanding of. So this is about defining the purpose of your system and trying to understand, why you're exploring your system. For some people, it might be about understanding. For other people, it might be about shifting and deciding to do something about changing that sort of system. So that's the first step. The second step would then be to try to get a picture of the system that you're talking about. So this is where it's very useful to get other people involved because other people will have different perspectives. So when I've had to mediate a conflict between two teams, a good way of building a shared picture is getting a representative from both teams to share their ideas about their perspectives. Now, typically in that sort of an environment, one team has very deep perspective on one side of the problem, and the other team has a very different perspective. And so combined, we're kind of building the shared picture, right? And so this is where you're trying to understand what are the elements, what are the relationship between those elements, but also what are those sort of feedback loops that you might notice across them. And so this is where once you have your purpose and your goal, trying to build that sort of shared picture and the interconnections might already give you some insight that other people didn't have. So in this example with mediating a team conflict, one team member from one team may not realize the other team is actually solving a very different problem, or they're optimizing for a very different problem. So that's one of the very good benefits of actually bringing people onto the same page, is that it just expands their perspective and awareness. And particularly if you involve other people in your organization, if you're butting heads with your project management office or some process, helping to get somebody from that sort of side might open and expand your perspective that at least you understand they're not maybe demanding unreasonable things, but they're optimizing for different goals. And so, I think that's the second part of trying to build that picture of the system. And you often learn a lot through that process. You learn new information, hopefully different perspectives and different people or agents within your organization. Now, the third step is then deciding if you actually want to do something about that, right? So if you maybe by building that picture, that helps you understand and explains why you are in the situation that you're in. The third step there may not be a lot of reason to then change that, right? You may understand, okay, there were things that I just didn't understand that we needed to do, right? So I didn't really understand that we were getting audited every quarter, and therefore this person was always asking me for a written report of what is our licensing issues, or which open source licenses are we using, or what security vulnerabilities. To me, it just felt like more work. But now that I understand that there's a purpose to that, it makes sense, right? And so the third part then is thinking if you want to shift that system. And so this is where it's a little bit more difficult, because it's a lot more easier to do this in a workshop, going through a sort of concrete example of trying to understand, what are those interconnections? What are those loops that you're looking for? And are there things that you want to do to either increase those loops, decrease those loops, or to add in new feedback loops that didn't really exist, right? So this is one of the great things about the way that teams have evolved over time. So when I started working in software, for example, it was very common that as a developer, your goal or your job was done when your project milestone was passed and it was thrown over to a testing team who would furiously test your software, right? So there may be a couple of bugs that come back, but you don't really have to worry about that. Over time, the speed of software has sped up. And one of the interesting feedback loops that have come in is, if there are production problems, the originating source of where they come from, aka the developer, gets to know about those problems. And so this is the whole idea and philosophy behind Amazon probably labeled it best or earliest with the "you build it, you run it" philosophy, right? So that's introducing a feedback loop that didn't exist previously. In organizations before that, it was like a operations team or a poor support team that would have to always deal with things and find workarounds, but the source of that problem was never addressed, and the person who created it never knew that they had created a problem.
Right.
And so this is something about adding in that sort of feedback loop. And so that's the third step, is that once you have that visual, trying to understand what are the things you're either trying to slow down, speed up, or maybe add in a new feedback loop in order to sort of intervene with the system behavior that you expect.
Thank you. And are those all the steps? We're done.
Yes, yeah, absolutely. Yeah, so I'm trying to keep it as simple as possible.
All right,
So,
all right. Sounds good.
Once you decide to do something, I think definitely an element of it is, deciding how and when to do it. And like with everything in software, it's an iterative process, right? So you'll need to decide when to review, have you actually had the impact that you had? But then you have to go through that process again of, just like with software, reviewing, do you want to make any changes to that? Other changes that you have doing well? You have to decide on your review cycle, but that's as simple as it is.
Wow. Thank you. Thank you so much. The first thing that you were explaining about looking at the interconnectedness of understanding how some people or some of your colleagues might be aiming towards different goals within their own sort of position or their own work step really made me think about service design and how it encourages people to stay in the problem space without judging or jumping to conclusions. And I found it particularly hard when I held the service design workshops to get engineers to sort of not try to fix the problem immediately, but kind of stay in the same space and try to understand every agent within the space. Do you have any kind of experience with that or any comments on that?
Yeah, I think a lot of this is breaking old habits. So, engineers are problem solvers, right? That's kind of what their key responsibility is, and that's how they perhaps see their day-to-day job. And so I'm working with problem solvers, trying to do that. The way that I try to think about it is to frame the situation of saying we will get to problem solving, but there's a specific time later. This phase where we're at is more about exploring. It's more about information. Now, once again, habits are hard to break. And so people might natively, and individuals, not just developers, everyone likes to solve problems. Everyone likes to come up with good ideas, things we could do. But it's about sort of being explicit about when the problem solving will happen and helping people, once again, creating that visual model. This is something that I would do if I was facilitating a workshop, of trying to create that timeline of trying to say, okay, this phase, we're exploring agents or actors and their different sort of needs. We're going to focus on that first. And later, we're going to talk about what we're going to do to help satisfy those needs, because it's a good way then to remind people linearly, okay, I hear you talking about a solution, Right now, we're going to come back to talking about this person and what their needs are.
All
So
right.
that's a personal tip that I found very useful.
Thank you. Thank you. And with that said, let's jump right into the tools. You have mentioned a few, making sure that you create the purpose or the end goal for the system. You also talked about modeling and drawing the boundaries of a system. What are some tools that are useful when applying systems thinking? And if there are some that are specific to systems thinking?
The simplest tool that I really like are basically, if you can do this in person, then it's sticky notes and a whiteboard. And the reason for that is you want to be able to move things around really rapidly. Similarly, a good parallel for a lot of our software sort of engineers here is if you're ever playing around with, say, a software tool when you're trying to build an architecture or a model, you often spend a lot of time playing around with the tool, getting distracted by what it can and cannot do, rather than actually describing the model. This is one of the reasons why I think a lot of people gravitate towards back to a whiteboard, particularly with discussions and things like that. You need it highly adaptive and dynamic. Probably similarly, if you have meeting notes, right? So if you're waiting, or project plans, it's very painful if you're watching somebody have to fiddle around with a tool while they're trying to update it in the meeting. So that's why I'm not a big fan of using complex tools for systems thinking. It's important more about the discussion and capturing that and the reacting to that. And the most adaptive approach to that I've found personally is keeping it as simple as possible, sort of low fidelity as possible, of using sticky notes and a whiteboard. In today's world, distributed sort of world, that becomes something like an equivalent. So something like Mural or Miro, which allows you to brainstorm lots of sort of elements and to try to adapt the sort of connections between them. There are tools that are more specialized towards systems thinking, particularly if you're trying to calculate. So if you can actually measure the relationship between elements and inputs, outputs. But for a lot of the purposes in software, A, we're not great at measuring things, but B, I think it's just more useful about that exploring the system. And so I would actually just encourage people from trying to go to a software tool first. Similarly to when everyone's trying to talk about an architecture diagram, I would keep it as simple as possible to improve on the discussion first. And then, think about digitizing it later. So that would be my recommendation.
Thank you. Thank you so much. Some of our listeners might know that I sometimes highlight the fact that soft skills and communications are very important, even though we work in IT or we identify as software engineers. We work with people, and it's one of the greatest skills to be able to communicate with people.
Totally agree.
With that said, perhaps let's talk about what team dynamics might arise in a software engineering team. So our listeners are mostly tech leaders and engineering managers. Let's say you have a product that your team is working on. What kind of models would you build for them if you were to engage with their team?
So I think there's a couple of different things. So models for me is like quite a broad category. So there might be a model about, do we understand the product of what we're actually building, right? So that would be one shared model I would build. And I've worked in teams where people, once again, get allocated those tasks, but they don't really understand the sort of broader picture. You talked about service design before, right? And I think one of the parts of service design is identifying who are the end users or customers or your target people. And that's another model that I think is definitely worth building with a software team, right? Who are your personas? Do people know what their priorities are? Do they understand each of their different needs? Because it's hard to come up with a good solution if you don't really understand who is going to use something at the end of that. For our software engineers, it's very important that everyone has a shared technical vision or a shared technical model of how they think about their software. So the hard part about software is we build these visual models of how code is related. This code goes into that component there or that service. We have tests over this part of the code base. And so trying to construct like a technical vision model, which helps you understand your technical architecture effectively, or to help you communicate sort of abstract concepts, like if your system does processing of data in a certain sequence, a sequence diagram is often useful to describe that model because it's an important, say, domain concept. A domain model is also just as important of, do people understand, okay, get the software out of the way, what is the essence of our domain of the product they're actually building and what are the relationships in that? Then, when you have that domain model, the interesting question is, that's your essential domain complexity. You can't get any simpler than that. How does your software look compared to that, right? So there's often a lot of accidental complexity or non-essential complexity because we have tools and we have frameworks and libraries that force us to do things. We have processes, we have to write documentation for some of these things. And so it's interesting to sort of think about, if you have your domain model, that's as basic as you can get, regardless if you have software or not. What extra things do you have, and what can you do to reduce that as well, right? So as a technical leader, the less work that your team has to do that is non-essential, the more you can focus on delivering value to customers and what is actually needed as well. So there are a lot of the models that I could definitely think of off the top of my head. I'm sure there's many, many more, but it's a very broad question. So I could probably talk about this for hours.
Yeah, but that was a taste. So whoever is more interested should go and, I assume, check out your blog. But before we get to that part, do you have anything else that we haven't touched on and you think is important to share with your listeners?
In terms of the topic of systems thinking, what I would encourage people to do is, it's not something that you can easily just read about. So for me, I came across this in Peter Senger's The Fifth Discipline book very early in my career. And for me, it's one of those things that I've taken into how I worked over the last couple of decades. And so it's something that you should think of as a habit, or something that you sort of practice and build into how you work. And it's important to therefore experiment with it as well. So if I was to encourage anyone who's thinking about exploring systems thinking, pick a small problem, draw a small part of your system, and start to practice some of these things. Talk to people, involve people, think about the things that you might shift in that. Don't try to build the picture perfect system, because there is no picture perfect system. And don't try to draw something that's too big, because it's going to be probably too complex to understand and also too complex to influence. So just like with software, start small, but it's important to practice, to iterate, and get better at it.
Thank you so much. That sounds like a much more chewable chunk than just like jumping right into the whole of it. Thank you so much for spending time with me. Where can our listeners follow you or follow your work?
Great, thank you. So people can find more about me at my website, patquah.com, also the same Twitter handle. And if you want to learn more about systems thinking, I've got a course at the techlead.academy.
Thank you so much. Dearest listeners, you just listened to a conversation with Patrick Quah, and he is a seasoned technical leader with lots of great things to share about systems thinking and many other topics. So go ahead and check out his website and see if you can get in touch with him or you can learn from his work. Here's a quick reminder for you. If you sign up for the Level Up Engineering newsletter, you will receive every new episode 2 weeks earlier than the rest of the world. Click the link in the show notes and join our engineering leadership community. With that said, I thank you for staying with Level Up Engineering. I am Karolina Tóth, and I hope to see you next time.
Thanks for staying with Level Up Engineering. If you enjoyed this podcast, so will your friends. Share this episode on your favorite social networking platform. To stay up to date with our content, follow Level Up Engineering on Spotify, Apple Podcast, or Google Podcast. Brought to you by Coding Sans, a software development agency building web applications with Angular and Node.js. Check them out at codingsans.com.